Hello students, I, Pooja Garg, your mathematics guru, welcome you in my online classes for class 9th. I hope you are spending quality time with your family and learning mathematics concept through these videos. As in previous video, part 1 and part 2, based on chapter number 1, number system, in that we discussed a lots of concepts and related questions. And I hope you people are solving assignment questions as well. So today, through this last part, that is part 3 of this chapter, I am going to teach you two more concepts. That is, the very first topic is nth root of real number, laws of exponent for real numbers, and the next and the last topic is representation of real numbers on a number line. So let us begin with the very first topic, that is what is nth root of a real numbers. So here you can observe as square root of 2 is equals to 2 raised to the power 1 upon 2, means when we remove this radical sign we can put power as 1 by 2. Same way when I remove this cube root, then I'll get power as 1 by 3 and so on. So in general, nth root of x is equals to x raised to the power 1 upon n, where n is a positive integer. You can see this concept through one example. So here have a look. As we know, square root of 100 is 10, right? So here square root means here we have 2, right? So here we can write it as 100 raised to the power 1 upon 2. Now 100 we can rewrite it as 110 square and whole power 1 upon 2. So using laws of exponent we can multiply these two powers. So here what we'll get? 10. It means square root of 100 is 10. So we can conclude that square root of 100 we can rewrite it as 100 raised to the power 1 upon 2. Now the next topic is laws of exponents for a real numbers. Before starting laws of exponent for real numbers, I am going to just introduce that you have used already these laws of exponents in your previous class in chapter exponents and powers. So here also we are going to apply the same laws but for the real numbers. So let us start. Let a and b, where a and b is greater than 0, be two real numbers, means here I am talking about a positive numbers, and p and q are rational numbers. Then we have these laws. These are 7 in numbers. So very first law you can observe you have done earlier as well. Just the difference is that here a and b are real numbers, where p and q are the rational numbers. So very first law is, you can observe here base are same in multiplication but the powers are different. So what we'll do? We have a common base and add the powers. Now the second law, same for the division. Again base is same but power is different. So what we'll do? With the common base we'll subtract the powers. Now the third one is, now what you're observing in the third one, base are different in multiplication and power is same. So what we'll do? We'll multiply the base with the common power. Same rule we can apply for the division. We'll divide the bases and common power p. Here the fifth one is, we have the double power, means a raised to the power p and whole power q, means when we have double or triple or more than that, what we'll do? We have a base and we'll multiply all these powers, that is p into q. And next, a raised to the power 0, means if power is 0 then it always gives us 1. Next, if power is negative and want to convert into positive power, then what we'll do? We'll do the reciprocal of base. Now we have some examples based on these laws of exponent for a real numbers. So let us see. The very first example here, 27 raised to the power 1 upon 3. So how we can simplify it? Can we rewrite this 27 as 3 raised to the power 3? Because the prime factors of 27 is 3 into 3 into 3. So here 3 raised to the power 3 and whole power 1 by 3. According to the law of exponent, we can multiply these two powers. So ultimately what do we get? It's 3. Yes. Now see some more examples. Here what you are observing in the second example, base is same and power is different in multiplication. So what we'll do, with the common base, we'll add the power. So after adding the powers, we'll get 13 raised to the power 12 by 35. Now see the third example. And I think so you people are observing that I have done this in two different ways. So see the different ways, and they see in both the cases we are getting the same answer. The very first way, here I have written 8 as 2 power 3. 27 as 3 power 3. Then I applied the laws of exponent in both the cases. So I'll get 2 into 3, which is equals to 6. And in second case, what I have done, here I am observing one more thing, that powers are same but bases are different. So what we'll do, we'll multiply the base and with common power 1 by 3. So here it is 216 raised to the power 1 upon 3. So if I'll solve it further, so I'll get it as 6. Just you observe. See the fourth example now. 1 power 3 plus 2 raised to the power 3 plus 3 raised to the power 3 and whole power 1 by 2. Here I can't apply the laws in this bracket because these laws only for the multiplication and division. So what we'll do, just we simplify it. Here 1 cube means 1, 2 cube means 8, 3 cube means 27 and whole power 1 by 2. So if I'll solve it further, I'll get it as 6. Now here we have one more example, simplification. You just observe and find out how to do. Though this concept we discussed in previous video, how to simplify these roots. Now based on this topic, I have some assignment questions for you people. You can try to do exercise number 1.6 from your textbook and write it down this question for simplification. Now, after this, I am going to discuss how to represent real numbers on a number line. So here you know what are real numbers? Yes, real numbers are the combination of what? Rationals and irrational numbers. So what is a decimal expansion of these numbers? If the number is terminating, decimal expansion, or non-terminating recurring decimal, so we'll get a rational number. But if it is non-terminating, non-recurring, then we'll get an irrational number. So first I'm going to represent an irrational number, how to represent on a number line. So let us see. So very first concept here, representation of these type of numbers on a number line, that is root 2, root 3, root 5, so on, as they are non-terminating and non-recurring. So for this, what we'll do, we'll draw a number line. As you know how to draw the number line. Here towards the right of the 0 we have positive numbers and towards left side we'll get the negative. But the distance between these numbers is always equal. If you are not going to take equal distance, then you will get the wrong location of the numbers. Now see the very first step, what we are going to do, as I need to represent root 2 on the number line. So what we'll do, I need to take some base distance. I need to take some base distance. So what base distance I'll take, how much unit I'll take. So let us see. I need to find a number whose square is less than 2. So let us start with 1. 1 square is 1, which is less than 2. If I'll take 2 square, that is 4, which is greater than 2. So what is a convenient distance? Here it is 1. So what I'll do, I'll take this base distance from 0 to 1 as 1 unit. Let it as OA points. Then from A point, we are going to draw a perpendicular. Again, that is of same. It should be of 1 unit. Then join OB. Now we get a right triangle. If you apply Pythagoras theorem in this right triangle, then we get OB as square root 2. So it means this distance OB is root 2. Now how to locate the point on a number line? After this, what we'll do, we'll measure this OB distance with the help of compass and we'll make a arc which intersect this number line on point C. So this point C represents the location of this point, that is root 2. So that is how you are going to locate this irrational number on a number line. Let us see one more example. Root 5. Now how to represent root 5 on a number line? Let us see. Here again the same concept I am going to use, that is 1 square is 1 which is less than 5, 2 square is 4 is again less than 5, 3 square is 9 which is greater than 5. So here I am going to take this base distance now as 2 units. Now again from point A we are going to make a perpendicular of 1 unit distance. Now in the same manner join OB and use Pythagoras theorem in this triangle OAB. Then we get OB as root 5. So again in the same manner we are going to measure this OB with the help of compass and will draw an arc. Again you can observe this arc intersect this line at point C. That is root 5. Here I have one more way to represent this root 5 on a number line. You can see by using this square root spiral. Here you can observe. Here what I did, I took a base unit as only 1 units in the same manner that I took in example number first. Let it be as A, as B, C, D and this as E. So have a look. Here in the same manner what I did, first this is 1 unit, again this is a perpendicular distance of 1 unit, where then I joined it and using Pythagoras theorem will get this as root 2 units. Now this is root 2, I will measure and I'll drop down the arc, I'll get a location of root 2. Now what we'll do, we'll take OB as a base and we'll again draw a perpendicular of 1 unit distance and we'll get a point C, then join OC. And again in this triangle we can apply Pythagoras, will get this distance as root 3. So again we are going to measure this OC and will mark an arc and this point represents root 3. And the same manner we are going to do in a spiral way. So see the last triangle, here I am getting this as 2 units and here I am getting this as a 1 unit. So after applying Pythagoras theorem in this, I will get this OE distance as root 5 and I want to locate this root 5. So I will measure this OE and will make an arc with the help of compass, and this point D is a location of root 5. Now based on this topic I have some assignment questions. So on this topic you can try to do exercise number 1.2 from your textbook and you can write it down, these 2 more parts which you can try. Now the next one is how to represent terminating decimals and non-terminating recurring decimals on a number line. So here I took 2 examples, 1.452, and you know it is an example of terminating decimals, and here another example I took 2.13 bar. Bar is only on 3 and it is an example of non-terminating recurring. So let us see how we are going to represent this on a number line, and this can be used by successive magnifications. So let us see. Very first one is I want to locate 1.452 on a number line. So very first step, since this number you can observe lies between 1 and 2. So yes, we got the interval. So it lies between 1 and 2. What we are going to do, we are going to divide this interval in 10 equal parts and name it as 1.1, 1.2 and so on. So here now you see the 10th place, it is 1.4. It means now it lies between 1.4 and 1.5. So have a look. Now I have done, I took this interval and I divided again this interval into 10 equal parts as 1.41, 1.42 and so on. Now you see the 100th part of this, that is 5. It means 1.45. So hence this number lies between 1.45 and 1.46. So again I am going to take this interval and going to divide this into 10 parts. So here we have the location of this point 1.452. Have a look. Same way I have one more example. Visualization of 2.13, bar is on 3, up to 4 decimal. 4 decimal means what? 2.1333. And with the same steps I am going to represent this on a number line. So have a look step by step. As this number lies between 2 and 3, So I divided this into 10 intervals. Then here the 10th part is 2.1. So it means it lies between 2.1 and 2.2. So again you see 2.1 and 2.2. Here again I divided this interval into 10 parts. Now you see the 100th place, that is 2.13. It means it lies between 2.13 and 2.14. Then again I took this interval and divided in 10 parts. In the same way I got this, the last one, and here we have the location of this point. So please have a look on this. Now based on this, I have some assignment question. On the basis of this, you can try exercise number 1.4 from your textbook and write it down these more questions so that you can do at home. And here I'm going to end off this chapter number 1, number system. At the end, I just want to inform you that do all the assignments given through these videos, which will help you out to build up your concepts. And guys, don't forget to like and subscribe my channel so that the notification of upcoming videos related to other chapters you will get. Thank you.